Good morning, everyone. Thank you for joining us here today to listen to us share some of the lessons that we've learned over the last year or so, helping teams within Google Cloud build generative AI-powered developer experiences. My name is Reto Meyer. This is Colton Canlis. And together we're engineering managers for the Gemini for Google Cloud first-party platform. Our team is responsible for providing the infrastructure, services, and operations support for teams within Google Cloud building products and features that utilize generative AI. That includes the Gemini Cloud Assist and Gemini Code Assist products, which you may have seen in yesterday's keynote or in various sessions throughout Next. Now, over the past year or so, we've been working closely with over 30 different first-party teams within Google Cloud. To make our jobs easier, we try and collect as much feedback and as many observations around some of the challenges and the ways in which teams have been able to overcome them as they build generative AI features and products. Mainly it's to make our jobs easier so that when the next teams go about doing the same thing, we can learn from those previous experiences. And today we've been given the opportunity to share some of that with all of you, hopefully to help ease your journey and that of your customers and teams. So first off, let's acknowledge that this tech is pretty amazing. At times it can appear almost magical, right? Like particularly when you're working with relatively unstructured text. It can have natural sounding conversations, it can write emails for you, it can summarize huge volumes of text and get straight to the point. But as software developers, we tend to have a slightly different set of needs. It turns out a lot of what we do requires really specific context and often quite a lot more structure than a natural language experience. As we know, LLMs are non-deterministic, so the creativity is wonderful. It enables things like code generation, debugging support, creative problem solving. But not all of the creative solutions and suggestions that it come up with are going to be valid, particularly in a coding context. Will they be syntactically correct? Maybe. Will it compile? Sure, maybe. But valid? Not necessarily. So if you get a response that is exactly what you were going to type in, it really does seem like a magical experience, like the future is now. But if the suggestion that you get is obviously wrong, something that even at a glance you're like, that's not right, then you start to wonder, is this something that I can even trust? And the answer is, honestly, you probably shouldn't trust outputs from LLMs at face value. And part of what we're going to be talking about is how you can improve the reliability, improve the correctness, etc. But even if the trust isn't 100%, that doesn't mean that you can't still create useful experiences for your end users. Secondly, LLMs are most impressive when being able to deal with the ambiguities of natural languages. But developer tools tend to work with much more structured data. Programming languages, CLI commands, structured data like XML or JSON or YAML. There's a lot less of this type of data available for language models to train on. Plus, natural languages are just a lot more forgiving in terms of structure. Right? When you think about natural language grammar, there's a lot of different ways you can phrase a question or a response and still have it well understood by the people you're communicating with. When you're working with developer tools, that's not often the case. You're expecting a very specific syntax, a very specific grammar in order to be able to do something for you. So another thing, for developer experiences, specific context tends to be extremely important. Natural languages tend to embed a lot of context within the question itself. And then more context allows more specificity in the answer that you're providing. But you can get a valid response based on really any question and then general knowledge in a particular space. As developers, we don't generally have that same luxury. Any given request requires a ton of specific context to be able to give a correct answer. What programming language am I working in? What development environment? What tools do I have? What libraries can I import? If you ask any developer a generic question, how do I do something in code? The answer is almost always going to be, well, it depends, right? Which is the same is true of the two most common questions we get asked, right? Like, is this possible and how long is it going to take? It depends. Right? You need context to be able to answer these questions in a meaningful way. And fourth, let's just acknowledge that user expectations around this technology are extremely high. Right? We can see that this technology is going to be revolutionary. So people are already expecting a lot. So we're kind of expecting tomorrow today and disappointed when it's not already arriving. And so again, hopefully today we can give you some tips on how we can bring that future a little bit closer. So you put all of these things together and we can see that GenAI experiences for developer tools is a significantly different problem space than for natural language tasks. And as such, they require a rich set of unique solutions. And today we're going to break down those experiences into 4 general buckets. Chat, which almost everyone is familiar with. Developer IDEs. Context menu experiences, where you select something, right-click and perform an action based on that context. And finally, background tasks. We're going to break apart each of these experiences and talk about some specific high-level things that we've learned for each of them. Now, first, I'm going to ask Colt to get us started with the simplest, or at least the least complex of our cases here, background experiences.
Yeah, thank you, Rado. So background experiences are really interesting and unique in the space of the developer tooling that you're going to be building. And the first thing is that this classification of experiences defines itself very simply that execution time is not an issue. Within reason, these types of experiences can run in the background for as long as it takes for the model to come to a solution overall, which means they are increasingly adept at handling operations on extremely large data sets. There we go. And being able to find particular correlations or information or event data inside of those data sets. So you can basically let this thing run, go to Vegas for a conference for a couple of days, and when you come back, hopefully it'll have an answer for you. Common requests look something like this. Here's a terabyte of data. Go find some correlation between these 2 data sets inside of that process, right? Now, if any of you have actually tried to build this type of technology, you'll quickly run into one of the first and most common problems that many of us see with LLM technologies, context window sizes. See, models, in order to hit specific performance and quality requirements, are explicitly trained to only work on subsizes of content windows. You can't include everything under the sun. So they explicitly point out and intentionally train on smaller data sets there. Now, the important thing you need to understand here is that every single model has different sizes that it's been trained on. In fact, the same model might have multiple variations of different context window sizes, which means you, as a developer trying to create this type of experience, need to find the right sweet spot between model quality, model cost, and context window size for the situation and use case that you're trying to build for. But the most important thing here is that even though that these models are running inference on GPUs and TPUs, which are capable of having gigabytes and terabytes of memory on the chip itself, these models are not trained with that much context availability, which means that no matter what, you can't actually throw a terabyte of data into the preamble of a model and expect it to get the entire correlation and context in a single shot. As such, we have to start leveling up what we're doing. We can't rely on the model itself. Instead, we need to work for something different. Now, outside of the GenAI space, there's a very common process, orchestration, or as we like to call it, out-of-core algorithms. These types of algorithms have existed for since the 1970s, when original CPUs couldn't actually contain enough information in their local cache. And so these types of algorithms have come together, and they work something like this. Effectively, whoop, wrong button there. Effectively, you have your orchestration unit fetching pages of data from your data source, and each page is roughly about the same size as the context window for the particular model, for the particular experience that you're looking at. This page is then passed to your model along with whatever preamble and prompting information you may have in order to find the context that you're looking for. And then the results of this for this particular page is stored in a data cache. Then this entire process is basically repeated, right? You want to go through and make sure that each page for the data set is handed to the model and each result of that is handed into the cache. Once done and all of the data inside the data set has been looked at, you can combine all of the cache results, send them to the LLM to get the final result together. Now, any of you who've ever built one of these out-of-core algorithms immediately is going to see a flaw in this diagram, right? And that is what happens when our results cache is larger than the actual LLM context window itself. For this, we have to bubble up to a more interesting version of this algorithm, which is hierarchical out-of-core algorithms, which effectively allows us to continue this process over and over again, each time modifying our context window process to find different relationships, different truncation processes, and different analysis to reduce this down to the point that can actually fit inside of the context window for the LLM that we're working with. Now, again, none of these algorithms are unique, right? If you go search for out-of-core algorithms, you're going to find a ton of examples. You're going to find a ton of code that you can work with directly. So this isn't unique to GenAI. But there are two important things to think about when you're building this type of experience. The first, of course, is that you will need to do some explicit level of prompt engineering, right? If you actually want your models to find the context in this regard, you need to go through the process of prompting in the right way. And so something as simple as this will honestly work, all right? You've got a prompt which basically says, here's your task. You're looking at one page of data at a time. And then you have some bounding requirements on the right way to answer and what to do if there's no association that we're looking for. So even though this is an older algorithm combined with a newer technology, you will have to budget some time in your development cycle. Anytime a model changes, your algorithm changes, your RAG data changes, all of this has to be updated altogether. So make sure you're planning for that. Now, the second important bit that's worth talking about here is actually that these models are pretty new. And even though this technology is pretty amazing, if a model has not been explicitly trained to do a specific type of action, the expectation of quality of that action is generally undefined, right? Which means that you really can't rely on the models for everything. But let's be honest, we've had 80 years of software engineering here. There's a bunch of other tools we should be leveraging to help the models do their jobs better. So for example, we could actually take this massive database, throw it into BigQuery, and run the correlation function on it. This will actually give us a set of time series data, which we can then truncate and combine to actually fit inside the context window before we go through our out-of-core algorithm. This information can then be used to create a table like this, which helps the model find those correlations inside the data, running a little bit faster, giving a better operation. So when combined together, we see these out-of-core algorithms with use of existing technology can actually go through the process and find these insights inside of your data at a much higher velocity without a human in the loop. And for those of us who do big data lake analysis, this is a really, really cool feature to put together. But speaking about velocity, a lot of the cool things we want to talk about are actually shared with the next section, which is context menu experiences, and Rado's going to take care of that.
Great, thank you, Colt. So, context menu experiences. They differ from background experiences in some very specific ways. One big clue is kind of in the name, right? Context menu-driven experiences are relative to a specific context. Generally, it's going to be something in the user interface that you've selected, but it doesn't have to be a specific selection, right? It could be the file or even the project that you're working on. But importantly, it is context that the user is aware of, and it's happening within the user interface itself. Now, Google Docs is a really good example of what a context menu experience looks like for a natural language type experience. You select some text, then you ask the LLM to perform some action on that. Summarize, bulletize, formalize, casualize. Really, you're trying to perform some kind of canned action based on a selected piece of context. And LLMs are great at this kind of unstructured natural language transformation. But generally, developer tools require much more structure, particularly in terms of the outputs. And context menu experiences are actually a really great way of being able to encapsulate that and have much more predictable outputs that can be used within your tooling chain. So let's go through it. What are some of the unique things about context menu experiences? Well, they allow you to offer a specific set of actions where you define the domain and have a specific set of expectations that you're able to define in terms of what those outputs look like. So you can focus on the things that you know will provide a great experience for your users. And because you control the prompt and any pre or post inference transforms that happen to that data, you can really optimize to get a very specific, optimized solution for the specific use cases that you're trying to build. Also, context menus don't have to happen in real time. Now, they don't have the same availability as the background services, which can take a weekend if that's appropriate, but they don't have to be instantaneous. They can't take forever though, right? So you do need to have a timely response. You need to have some sort of feedback to the user in the order of hundreds of milliseconds to acknowledge that something is happening. And then you probably want to generate a response in the order of single-digit seconds in terms of being able to get some useful feedback back. Based on that, you can operate with reasonably large data sets, not big data, as Cole was talking about before, by any means, but you can certainly get more context from the client. You can, because you know exactly what kind of context, what sorts of information is going to be useful for being able to perform the action that you're defining here. So you're able to really improve the specific response that you're creating that shortcut for. If you put all of this together, you can see how context menus are a particularly useful technique for developer tools. You can limit the domain of actions, take your time to really understand what the perfect prompt is going to be able to generate the outputs that you're looking for in the structure that you require. And you can use additional client-side context to be able to find the right information you need to be able to provide the best outcome for your user. Ultimately, what you want to do here when you're within a developer tool is create outputs that are structured in the right way, that they can be predictable, parsable, potentially lintable, and programmatically validatable. So let's look at what that means in practice, right? Let's start with something relatively simple. I'm in my IDE, I select a file or a class or a function or just a snippet of code and choose the context menu command to explain this code. Now, putting that directly into a chat experience like Gemini actually gives a pretty good answer, right? That's not bad, but it's kind of long. What I want is something much more structured to be able to display within the context of my IDE. I want a couple of sentences. I want it to have more context awareness of the project that I'm working on. The default Gemini response only has that particular snippet of code. So its answer is hedging, right? It's like, well, it looks like it does this. I think it does that, because it just doesn't know what else is in my project. So it's too detailed. It lacks awareness. I want to be able to have a much more structured output. Now, because this is behind a context window, behind a context menu, I can mess around with a prompt that gets exactly the sort of answer that I want. And that includes inserting as much of my source code as is going to be useful to be able to generate that response. Now, if you're working with a model like Gemini 1.5, Gemini Pro 1.5, which has the million context window, maybe that just means shoving everything in. But a million tokens is still not the size of most people's entire code bases, right? It's a relatively small project. So either way, you're going to have some kind of client-side planner which figures out what is the right code that you want to include here to give the appropriate amount of context to be able to power the particular function and user feature that you're implementing here. That may mean selecting particular source code. It may mean summarizing some or all of it. Again, this is something that you're canning, you're putting behind a menu. And so you're able to keep working on that until you're able to reliably get the kind of outputs that you want. So here you can see I'm kind of getting what I'm wanting here. It's short, it understands enough context about my project to be able to give a specific answer about what this code does in the context of my overall project. But it is still non-deterministic. Right? If I run this 3 times, I'm likely to get 3 different variations. If I turn the temperature up on the prompt, it's going to be potentially quite wildly different. But maybe that's not a bad thing, right? Like creativity and being able to get different kinds of responses is one of the powers of LLMs. So why don't we instead try and harness this? So we don't have to be super fast here. We can take a few seconds. People aren't expecting a back and forth through a traditional chat interface. So we can take a little bit more time and do some more post-processing. So let's do that then. Let's actually ask it 3 times, potentially with 3 different temperature values, and then ask the model to pick the best response or consolidate those 3 responses together to give a more comprehensive answer. So you can see the model here of what we're trying to do is to encapsulate more and more complex post-inference transformations hidden behind a simple context menu item for the user. And we can make sure that they're formatted in the way that we want them. Now, this is still operating on natural language, so it's cheating a little bit. And it's the kind of cheating I like in that it's leveraging the underlying skills of the technology that we're using. So that's great. But we can do more. We can use that same approach, and it's even more powerful when what we want is for the output to be much more structured in a specific way, particularly when the response that we're getting back is something that can be objectively determined to be either correct or incorrect, right? Things like code. Let's look at an example like this, where the output we want is a JSON object that defines the request to delete a virtual machine. On the left, you can see the first output, which produces a syntactically incorrect response. Right? It's just wrong. It's missing a close brace. But we have tools that allow us to find things like that. We have linters. We have all kinds of offline tools that live in our CI/CD systems to help us find these sorts of errors, which developers can make just as easily as an LLM. So why don't we take that first response and then pipe it through some of our code quality tools, and then ask the LLM to look at the initial code and the response errors that we're getting from this tooling and take another pass. This time asking it specifically to fix those errors, right? Here's some code we got. We ran it through some tools. These are the errors that we found. Please fix those errors in this code. And we could do this multiple times, or with multiple tools, or multiple tools multiple times, right? All of which should be improving the quality of the output. Our only limitation there is how long is it going to take so that we're still being able to get a response back to the user in a relatively timely fashion. So we can check for syntax errors, we can run lint checkers, we can potentially try and compile the code to see whether it works, and then ask the LLM to fix all of those things using these deterministic tools before providing a final response. One way to think of this is as kind of a new version of sanitizing your output, or trust but verify based on LLM outputs. All right. So let's then take a moment to really deep dive into some of the possibilities with the IDE experience itself. How do we go beyond these context menu-driven examples and optimize an experience specifically for engineers writing code within an IDE? Colt, can you walk us through some of these examples, code completion, generation, unit tests, all those sorts of things?
Yeah. We got to grab the clicker in the right way, otherwise we progress the slides correctly. Yeah, so hey, software engineers, raise your hand. Yeah, everybody in here? You spend a lot of time in your IDEs, right? And this is the new hotness, being able to do actions with LLMs inside of your IDE space. Now, code IDE experiences are really, really unique because of the things that we've talked about so far. This one has really strong opinions about things. So first off and foremost is that in this space, creativity is less important than accuracy. Right? The types of randomization and non-determinism that makes LLMs so great at natural language creative tasks actually become a hindrance in this space. If the LLM hallucinates the wrong function name or puts a close bracket where someone doesn't want it, they generally consider that the output is incorrect or bad, right? So there's a general concept of when an engineer sits down at their IDE, they expect a right and a wrong answer. This is an entirely different mental space than someone sitting down trying to get a paragraph written or an email updated, right? So this is a new problem and a new area. Our internal tests actually show that this is so difficult that an engineer that copies and pastes a block of code from the internet that they've found are more forgiving when that block of code has errors in it than the same block of code returned from a model. Right? On one of those, they're willing to throw up their hands and say, no, we're not doing this. On the other one, it's like, I'll fix it. Don't worry. I got time today. Right? So expectations are extremely high, which is a problem because when you consider the state of the models, the fact of the matter is that they're just not as good at synthetic languages as they are with natural languages. I mean, consider the entirety of content on the internet. Right? When you actually look at all of the symbols, all of the characters, all of the data, synthetic language information only occupies a fraction of the percentage of all of that information, which means that there's just less symbols to train on for these models. If any of you actually want to go and take a model and make it better at the small talk programming language, you're going to be really hard pressed to find 1 billion symbols to train on to make the models better at that domain. As such, we just have to simply understand that the current state of models aren't as high quality with synthetic language as they are with natural language. And worse off, when you actually get into the implementation details, things start to go crazy here, right? When you look at an IDE experience, you actually realize that these are entirely multimodal. You have one product, which is code generation, another product, which is code completion, another product, which might be right-click code transformation, and that doesn't even count chat. Right? So there's actually multiple products that you have to build in this environment. Each one of them has their own data stack, their own transform sets, their own requirements for toxicity, recitation, and everything else. So this gets really, really hard because every single one of those has to meet that accuracy and expectation bar that engineers come to the IDE with. This gets even more difficult when you start considering the multidimensional aspect of this, is that there's hundreds of programming languages that every engineer sits down at and expects the model to be perfect at every single time they hit Control Enter or the Tab key, right? expectations are really high. And this doesn't even count the fact that to do a simple task, you may actually have to include all of the other NPM libraries, pip libraries, Python stuff that's included outside of your project that may only exist in the application during compile time, right? But you as an engineer may understand what functions are in those libraries and what you should be using, but the model doesn't have access to that thing. As such, the ability for a model to give accurate answers with respect to coding tasks in an IDE has everything to do with the context that's provided. And we're going to dig into that a little bit here. So now, most folks who actually go through the process of building an IDE implementation start with something very, very simple like this, right? They basically say, here's the user's cursor. Everything in the file that's before this cursor is the prefix. Everything after the cursor is the suffix, right? We transform that, put it together, and we ask the AI to basically fill in where the cursor is based upon this information, right? Pretty simple. But the truth is that engineers in the house, we don't code this way, right? We take a lot more context into account. We think about a lot more things. When that cursor is sitting there, before we type a single character of code, we're considering all sorts of information. What are the other functions in the other files? What are the APIs I need to call? What is the difference between API A and API B? What are the APIs in the included libraries? Right? What is the compiler settings that I'm targeting for? What machine am I optimizing for? What platform am I optimizing for? Before we write a single line of code, all of this information is going on in our head to sculpt the way the answer occurs. As such, if we want our models to start getting the quality of answers in the same regard, we have to start providing this information to the model in the same respect. If we want it to start acting like a human, we need to give it the capacity to have the same information that's in our brains at the same time, right? Of course, this runs into the same problem I was just talking about, limited context windows, right? You can't just simply throw every package that your model is including at the context window and expect it to get the right thing. So we have to do something a little bit different. To highlight this, we need some concept of local RAG. Right? A lot of the times, all of the attention right now, the entirety of the industry, we're focused on online RAG, right? After the prompt goes to the API, what data can you fetch from the internet to make the response better? But in the IDE space, the local RAG is the important bit, right? Do you have the right file context? Are you including the right function headers? Things along those lines. To build this on the client side is actually a non-trivial implementation, and it looks something like this. Effectively, you have to take into account the user's context. This needs to be handed to your planner, and then your planner needs to go through the process of deciding what information in the local IDE space is useful to solving this particular problem. Fetching that data and then sending that off into the prompt in the right manner to actually be executed. I like to say that prompt engineering is the new bin packing, right? Anybody ever deal with bin packing algorithms? One hand? Nice, thumbs up. Two hands, yes. Fantastic, sorry, I love bin packing. Moving on. So to go into this a little bit, we've worked with a lot of clients who have implemented local RAG and planners in a lot of different ways. The most robust way to do this is something that looks a little like this. Effectively allow a background task to run in your IDE that goes through the process of segmenting and snippetizing all of the information in your local environment. So each block of code, segment it together, figure out what your boundaries are, create some additional information, effectively create local embeddings for all of this data that you have. But not just the source code files, your project settings, compiler settings, anything else, right? Now, as the user takes actions, go through the process of actually creating scores for each one of these snippets that relate to how important this snippet might be to the action that the user is going through at this moment. This allows us to then simply do a sorting process to figure out which of these are the most important or the most relative to the action being taken, regardless if it's generation, completion, transform, or chat. And then this allows us to easily put it together into the prompt and send it to the backend. Altogether, this is a robust strategy. Now, there's nuances that each of you will have to go through the process of modifying and changing depending on, what the language is and what the information is. But in general, something like this is really, really valuable. And of course, this is only on the client side. We still have to think of all of those remote or exo fetches that we have to fetch on the backside too, right? So imagine if the block of code you're trying to generate or the code completion that the user wants actually needs to have specific API information from a package that's only included at compile time. For that code to accurately give that response, you need the ability at runtime behind the API to go fetch maybe documentation about that library, or the APIs themselves that might be somewhere, or the open API spec, and bring that into memory so that the model can accurately solve this problem for you, right? It doesn't get a chance to grab a cup of coffee, go to Stack Overflow, and come back, right? It's expected to do it immediately. Altogether, there's a lot of amazing other things we can talk about in the IDE space, but I'm going to be honest with you. They're very, very similar to the same problems that we find in chat. And for that, I'm going to hand it back to Rado to talk about.
Fantastic. Thank you, Colt. Gave it to me upside down.
That was on purpose.
I know. All right, chat. Chat is the Wild West. All right, you give a user a text box and ask them to put something in there, you have no idea what they're going to type, right? Whatever you think they're going to type is almost certainly wrong. And you'll find that out in alarming ways as you try and build this chat experience. There are some good sides to this though, right? We do get the ability to support whatever modalities the underlying LLMs can support. So text, obviously, but also video, audio, images, right? It's all potentially in play, both in terms of the experiences that you can create for your users, but also what your user expectations are going to be in terms of what you're able to support, right? As soon as you, like we said, they'll put anything into a text box. If you now let them also add images, add video, add audio, it's going to hugely scale the potential things that they think they're going to be able to do within this experience. And those experiences can be extremely wide-ranging, right? It's basically a blank slate, a blank piece of paper. You can have interactivity, right? So you can start having conversations that enable multi-stage critical user journeys, which means you need to start thinking about how to support a request that is going to have critical context and information for you to be able to execute on it coming from multiple different prompts, because they are all just separate prompts that you're getting one after the other. And so if you're now trying to figure out how to do something or answer a question based on information that you got 5 sentences ago, particularly if a user has gone off on a tangent and have asked some other aside in the middle, right? You have to be able to figure out how to extract meaning from all of this information in order to provide specific actions and behaviors corresponding to what you're trying to provide and what users are expecting you to do. That also means being able to ask follow-up questions, right? So if you know what you can do, but you don't have enough information from what the user has given us so far, we have to ask. And the model itself isn't necessarily going to know that. These are our experiences that we're trying to enable. And so we need to then insert ourselves into that conversation and make sure that we're asking the right follow-up questions to get the information that we need. That interactivity goes both ways. It turns out that even though what we have is a chat interface, what people actually want is an assistant. Right? They don't want to be told, hey, all you need to do is copy this thing and then go to your CLI and hit paste and enter and then it gets done. It's like, you're the computer. If you know what needs to be done, just do it. Right? That's what people increasingly are expecting. And to be able to do that, you need to build a lot more infrastructure. You need to build libraries, tooling, extensions, plugins, all of these sorts of things enable us to be able to do that additional work to provide a more assistant-like experience for users, which is ultimately what a lot of people actually want. So let's start at the beginning. Right? Most teams start their chat implementations a lot like this. A lot like this. You take a prompt from a user that they've entered into a text box, you send it to the LLM, and then you get the response post-inference and you pipe it back into another UI element. It's pretty straightforward. And then reality sets in, right? It's never that simple because as soon as you start typing, it's an empty text box. They're going to start typing things which were not part of your critical user journey. Toxicity checking is the most obvious one, right? People are going to either ask questions that generate responses that you were not expecting and you really didn't want to put in front of a user. Also, the second thing which will happen is, the first thing is people will try and test something that they believe they know the answer to. The second thing is they'll try and troll your chatbot, try and make it say something bad, right? It's just human nature. Building that toxicity checking in is key. And then things like licensing and recitation checking to make sure that the compliance folks and the legal folks are happy with people being able to use these tools within your companies or put them in front of customers. These first two are pretty common. So a lot of the APIs that you can use for inference have them baked in. So it's sort of implicit in the products that you're using. But a lot of the rest of these things aren't because it's going to be specific to you and your experiences. chat history, for example, right? How are you building that consolidated prompt for each new conversational step, right? Someone needs to maintain what all of the previous questions were and what the responses were to send that in along with the new one so that the model is able to keep track of what questions are being asked and what it said in the past. People expect it to be a conversation with history, and that's something that you have to manage. And how do you handle prompts that you really don't want to answer, right? It's like people can answer anything, but you're just building a chat prompt to answer questions about cloud docs, right? Like you don't really want to answer questions about baking or politics, right? Like how do you make sure that you're dealing with stuff that's way off topic or that is too high risk, right? Like starts asking for investment advice, I'd really prefer that it didn't answer those questions either. Or even for things like Cloud Console, people may ask about cost. And that's relevant. That is a thing that is reasonable for someone to ask, but if the risk associated with the model providing an answer that's wrong or out of date or misleading is really, really high. So we need to figure out how to handle both things that are out of scope, but also things which are edge cases, which may be relevant, but not something that we want our model to answer. And how do you deal with hallucinations? How important is that? How important is accuracy in your use case? Is this creative, where creativity and hallucinations are okay, or where specific correct answers are much more important? And what are your CUJs? What are you actually expecting people to type in? What are the sorts of experiences and user journeys that you are optimizing for? How do you help funnel people into those particular journeys that you know are well handled? And as well, just practically speaking, LLMs aren't free. Like every inference call is costing you money. So how do you make sure that you're able to minimize those costs while maximizing the user experience? You can't always just use the biggest, fanciest model if you don't need to. That's money that you're spending that you may not have to. Do you need plugins? Do you need to build extensions? What behaviors are users expecting? How do you set those expectations within the context of a chat? How do you make it more than just an empty text box so that people are able to get an idea of what sorts of questions they can reasonably expect to get good answers for? It can really quickly feel like a really fractal problem, right? Everything you uncover has a whole series of complications that you need to deal with. Here's a representative flowchart of the things I mentioned earlier. Just to be clear, this isn't exactly what we've built for any of the products that we're supporting. They are, I'm sure you won't be surprised to learn, a lot more complex than this. But I'm hoping just as a visual representation, it can kind of give you a picture of how all of those different considerations can join together into sort of an information flow within the chat experience that you're building. So we'll start right at the beginning of that chat experience. Ensuring that toxic prompts are filtered out is an obvious challenge, both toxic prompts and toxic responses. But then finding that balance between blocking or redirecting what may seem like irrelevant queries, while making sure that the right prompts, the prompts that are part of those user journeys, are accepted. If we're too restrictive in how people are able to ask questions or engage with the LLM, we kind of lose the whole benefit of having a large language model. The whole point here is that people should be able to have a free-flowing conversation where they're asking a bunch of things in a way that makes sense to them, rather than having to guess what the phone support automated system needs you to say at this point to move on to the next part of the flow. A natural conversation is the whole point. So if you're too restrictive, that can really eliminate that benefit. As I mentioned to start off with, right, open text boxes, they invite chaos. People will ask all sorts of questions, some reasonable, some obviously not reasonable, some seemingly irrelevant, but then halfway through the conversation, you realize the thing at the beginning which didn't seem relevant actually is. They're just framing it and phrasing it in a way that's different from what you might have expected. Unlike traditional workflows, this is the big advantage of large language models. It's a chat interface that can, ideally, support whatever communication style your users prefer. For the first time, we're really trying to adapt to the user rather than having them need to learn what our UI patterns are in order to get work done on our platforms and our systems. So how do you build guardrails for a system like this, which is designed to work organically, which is designed to let users define what their workflow looks like? Well, there's a few approaches. You can start by creating a classifier from an LLM, but this can be challenging. It's not a panacea. It's going to be slow. It's going to be relatively expensive. And most importantly, it's still not going to be deterministic. You're using a non-deterministic system to help classify the intent of user behavior. Again, it could be wrong. So there is a place for this. But one alternative for this sort of early stage, if you know exactly what kind of functionality you can support, is to build a vector store to let you more deterministically figure out what are the user trying to do, and is this something that we have support for within our chat system. So you can do that by storing a bunch of representative types of questions in your vector store, using as many examples of this as possible. You can ask an LLM to give you more examples of this sort of prompt, just to try and create as representative a world as possible of the things that you can support. And then every prompt that doesn't support one of those, or doesn't register as one of those supported types of questions, is undefined, and you can route that accordingly. Maybe that means you then use a classifier to decide what you want to do with the queries which aren't supported as part of your regular CUJs. Maybe some of them you reject, some of them you rephrase, some of them you ask follow-up questions, etc. Oops. Another big challenge is figuring out which of the available client-side contexts that you have is going to be relevant to the specific question that's being asked at any given time. So if you look at this page, for example, you'll see multiple graphs providing important context, each of which may be relevant to a given query, but probably not relevant to every query. So the trick to solving this and figuring out what context to include is a robust planner system, something Colt mentioned earlier. And you're going to see increasingly becomes really important to being able to create the sorts of robust prompts that power a lot of these actions. So we have to understand that if we're going to perform actions in particular on behalf of users, we need some degree of parameter extraction. That means being able to match a request in a prompt to a programmatic task, to an API, a user action, or a set of tasks that can be executed. We need to be able to extract the parameters to enable that execution from the chat text, possibly from multiple iterations and different responses and prompts from the user. The point here is that we need to be able to extract those parameters, match them up to what we know is required for a specific set of tasks, and then be able to execute that task programmatically. So in this example, you can see that we've properly matched the delete autoscalers command with this CUJ script, and that we've extracted the data from that context. But there's a piece missing. The user didn't tell us which autoscaler to delete. So for this to work, that needs to trigger a multi-stage interaction with the user. To make that happen, we need a planner. We need to have some concept of what data is needed and in what order, what parameters do we have to have in order to be able to execute a task successfully. For simple CUJs, you can determine what data you need and make sure that that context is always included in each prompt. This is great for information retrieval examples. It may be enough to just pass as much local user context as possible, along with some grounding to reduce hallucinations and make sure that the responses are relevant. For more complex tasks, you're going to need a model trained to classify that task and what output is required as part of that data. And the greater the complexity, the more work is going to be required to understand what information you need, be able to manipulate the conversation to get that data. And finally, one challenge that's particularly relevant is that users have been trained to expect deterministic behavior that is canonically correct within the context of their developer tools. Right? If you ask Gemini or Google Search how to do something in Cloud Console, and it gets it 90% right, but the UI's changed a little, the buttons have moved around, maybe the colors are different, it's like, it's fine. You'd probably be pretty impressed if it's able to give you a right answer. If you do the same thing within the tooling, right? Now you're within Cloud Console and it's telling you to do something and that doesn't match up with reality, it feels wrong. It's like reading the documentation when it's out of date. And so that expectation, that user expectation for correctness when you're embedded within the product is much, much higher, even if the underlying model is the same. Right? See, this doesn't exist. I'm upset. Even if the model was perfect and never hallucinated, that wouldn't actually solve the problem because it takes a lot longer to retrain a model than most of our engineering teams are iterating at in terms of changing and improving the product. So even if the model was always right, If we can do things in a month and our team is iterating on weekly sprints, it's still always going to be out of date. And so one solution for that is retrieval augmented generation. We use RAG to provide that additional data to our users. Anytime where you're dealing with data that moves faster than the model training pipeline, that's when you want to use RAG. And don't forget, the model itself, even if that data is within the training set, it doesn't know when it's more specifically relevant. So again, you can use RAG to tell the model, hey, this specific data is much more important. Pay attention to it moving forward. Chat is fun. We don't have time to go through all of it. We're still learning every day. They're going to kick us out of the room very, very soon. So I'm going to give Colt -2 seconds to wrap us up.
Fantastic, thanks. Hey, thanks for all your patience today, folks. Just a couple of things to let you go with. All in all, there's 3 primary learnings we want you to take away from this talk. Number 1 is dev tools are a unique space when it comes to LLMs and generative AI. A lot of the research, a lot of the things going on right now are on natural language, yet our productivity from a software engineering space is inside of developer tools. This is a completely greenfield area, which has a lot of really, really unique problems that aren't being solved in the same natural language space. Second to that is models are not silver bullets. I think anyone in here should understand that by now, is that if you put too much reliance on the model, you're going to be disappointed. There are literally decades of algorithms out there that we've been using to solve similar problems to this that you should be leveraging in addition to LLMs. Personally, the thing I'm most excited about is over the next few months, a lot of the big innovations are going to come from using old algorithms and plugging new LLMs into them and seeing what cool stuff comes out of that. And finally, all of your problems are data problems. Period. Whether it's trying to train a new model on 50 billion symbols for COBOL or Smalltalk, or you're trying to do the same thing for a LoRa matrix that you get in serving, or even just trying to figure out what data you present from RAG, your software engineering team, who is mostly geared for software engineering practices, algorithms, and flow of that, need to start thinking like a data engineering team. And this is honestly one of the largest influencing changes that is going to happen to all of us as things move forward. With that, hey, don't forget to scan the QR code to get insight from experts in the field. Don't forget to leave some fantastic feedback for us. And with that, thank you for your time. Thank you for your attention. Enjoy the rest of the show. Bye.